Hi, 6th grade. Today we're going to continue to talk about polygons. For your last homework assignment, you had to classify numbers 1 through 8. Today what we're going to be doing is that we're going to be talking about diagonals. I said that we'd be doing that, and we're doing that today. So you're going to have to find the number of diagonals in each polygon. A quadrilateral, hexagon, heptagon, octagon, and then you're going to have to answer number 17 in your answers for exercises 13 through 16. Does it matter if the polygons are convex or concave? Explain, and we will be going over that. So, first things first is that we have to know what a diagonal is. A diagonal of a polygon is a line segment that connects two vertices and is not a side. So if you go over here to this example, all right, you see how we have vertices A, E, D, C, and B. All of the red things, those are diagonals. And you have to connect each vertice, which has a letter here. And every connection is a diagonal, but it cannot be a side. So if I were to start at point A, right here, point A, and I'm going to go to E. That is a side, so that does not count. A to D counts, so I'm at 1, 2, but that's a side, so that doesn't count. So then I'm done with A. So right now I'm at 2. Then I have to go to E. That's a side, so that doesn't count. A to C counts, though. So I'm at 3, 4. That's a side. 5. I already counted this one, so you don't count that one again. If I already count a diagonal, so I went from A to D, I cannot count D to A. So I'm still at, what was that, 5? Okay, moving on. Doesn't count. This doesn't count, doesn't count. Already there. Doesn't count, doesn't count, because I already counted it, and that's a side. So I should have 1, 2, 3, 4, 5 diagonals. Okay, this is confusing. I know it's confusing. We're going to go over another one, one that I have hand drawn for you. Okay, so here's your shape. This is a 1, 2, 3, 4, 5, 6 sided shape. So this is a hexagon. Yes, you do have your homework assignment and it is considered a hexagon. Now, I'm not the best artist, so it might be a little sloppy, but bear with me, all right? I'm going to start with this vertex here. From here to here is a side, so I'm not going to count it. From here to this point, though, is not a side, so that's 1. This, from this point to this point, is 2. This point to this point is 3, and that's a side. Now I move on to this one. Right here is a side, so that doesn't count. I'm at 4. I'm at 5. I'm at 6, and then that's a side, so that doesn't count. Okay, now I'm going to go to this one. That's a side. This is not a side, though. I'm at 7, 8, and I've already drawn this one, so that doesn't count. So I'm currently at 8. Now I have to go to this one. That's a side. This is not, though, and I haven't drawn this one yet. So 9, already drawn that one. I've already drawn that one, and that's a side. So I'm at 9. I go to this one. That's a side. That's already drawn. That is a super squiggly one, but it's already drawn. And then this one's already drawn, and that's a side. So I don't have any more to add. Now I go to my final one to make it all the way around. That's a side. This one is drawn. This one's already there, and I can't double count it. This one's already there, and this one is a side. So I have a total of 9 diagonals in a hexagon, okay? I know that this can get confusing. I do want you to practice this, all right? If you are like, oh my gosh, that all is super confusing, I can't keep it straight, I have a formula for you. This formula is down here. It's a little bit more advanced, so that's why I'm not starting off with it, but it's just PEMDAS, all right? The n, this variable stands for the number of sides. So if I was dealing with a hexagon, which I was, instead of n, I would put a 6. And it would look like this. So with PEMDAS, I start with my parentheses. 6 minus 3, I know is 3. So when I rewrite it, everything's going to look the exact same. Except for the 6 minus 3, I'm going to put 3. Because that's what 6 minus 3 is. Now I have multiplication and division. Multiplication, because we were from top to bottom or left to right, is going to come first. So 6 times 3 is 18. So I'll write this down here at the bottom. Carry my 2. Now this is a division problem. 18 divided by 2 is 9. So you do end up getting the same answer. It just depends on how you want to solve it. You can either count by drawing lines and going from each vertice, or you can use the formula. But make sure if you use the formula, you're also following PEMDAS. Okay, but you will end up getting the exact same answer. Now I want to talk about 17 real quick. It says, in your answers for exercises 13 through 16, does it matter if the polygons are convex or concave? Explain. No, it will not matter, because if you look at this example down here, now these are only 2 of the diagonals, but even though it is a concave because it's going in, you can still make a diagonal on the outside of the polygon and it counts. All right? So it does not have to be, diagonals do not have to be located inside. They can be located outside. So if it's convex, it shouldn't matter. So for this one up here, number 8 was convex. From here to here is a side, but from here to here, it would be outside. Oh goodness, that's terrible. It would be outside, but it counts as a diagonal. All right. Don't tell Mr. K I drew in the book. Okay. All right. We're good. I erased it. You can't see it anymore. Email me if you have questions, guys. You got this.